So today we'll just learn about some of the terms that are commonly used in the automobile manufacturing. So you might have heard of huge car manufacturers having different plants. Germany is the biggest is the biggest country with most number of manufacturing plants. Like you see the major car companies like Mercedes Benz, you have Ferrari, you have Audi, Volkswagen, all of these major car companies have set up their home base in Germany. So apart from that, you see a lot of new EV cars like Tesla, BYD. All these companies have their manufacturing plant. Tesla mostly started off in the US. Now they have their biggest gigafactory in China, which is producing a hell lot of cars than any manufacturer in the world. So let's discuss in detail. So why is automobile domain very important, right? Because it encompasses the design, production, marketing of vehicles, in which is also playing a huge role in the global economies. Maybe any country, a very core part of its economy is in the manufacturing domain, right? That's where they make money, and that's where a company's GDP also grows, right? It's an integral part. And also technological innovation. If you see a century ago, how people used to travel from one place to other, right? It all came under innovation. First, they invented the wheel, then they invented uh, four wheels, and then they put a cart on it, and then they found out how how do I get the perfect engine, right? Using what kind of fuel, which kind of fuel helps to have a better mileage of a car, right? Slowly, the design of a car changes. People wanted more luxurious, more cool looking cars, right? All these kind of things comes under technological innovation, and any automobile manufacturing drives the technological innovation of a country. So yeah, two types of transportation is the personal as well as the commercial part. Commercial transportation like the trucks and cars. Automobile domain involves a life cycle of vehicles from research and development to manufacturing, sales, and aftermarket services, with a constant focus on advancing technologies for improved performance, safety, and environmental sustainability. Right, there's an always big importance given to the performance. Like if you see in the recent times, more number of people want hybrid vehicles, right? It's a combination of both electric engines as well as the traditional engines, right? First, what happens is it gives an increased mileage. You see hybrid vehicles giving a mileage of more than 25, 30, which is only possible with hybrid vehicles, right? Coming to safety, safety nowadays is very, very important. So you have this NCAP rating for all the cars, and people actually value that NCAP ratings. A car with now more than 3 or 4 stars in an NCAP, those are considered very safe cars. So Volvo is considered the most safest cars. They promise like more than 99 to more than 90% of their consumers, they have never had an accident in a Volvo car. That's their challenge to the market. They are considered one of the most safest cars in the world, right? And environmental sustainability. So this is a very huge concern all around the world, that people, all the countries are very serious about being carbon neutral. That means because of burning of fossil fuels, a lot of carbon emissions is increasing, and to protect our world, they need to move to a more environmental sustainable sources of energy like solar or electricity, or even you have hydrogen fuels as well. And even in India, there new new sources of fuels have been found out using research. Like if you have heard nowadays, uh, Nitin Gadkari, our transport minister, is encouraging more of having ethanol based fuels. Why is that? It's because it helps in environmental sustainability. That aids to India's vision of being a carbon neutral country within like 2040. That is called environmental sustainability. So let's discuss on some of the terminologies that are used in automobile manufacturing. What is a chassis? The first one is chassis. So there's a structural framework of a vehicle, including the frame, the suspension system, and the other essential components. So chassis, you can also call it as body in white, where you have the sheet metal will be molded into different frames. Like you have a frame where you can fit the doors, and there is a frame on the front as well as the back where you fit the transmission system as well as the engine. And on the back you can also fit the tires as well as the back part of the transmission engine. So that pure body in white, as they call it, is called as the chassis. So even in chassis, they use a combination of metals, right? Maybe in the front of the car is where it is very critical when there is a collision. The metal should be strong enough to withhold that pressure. So they use very hard kind of metals. And where they connect the doors, you can have there is something called as a pillar, B pillar, and C pillar. Those are made from very strong metal to withhold pressure, and other non-critical parts are made of a lighter metal, right? Because the more stronger the metal, the more expensive it is. Based on different car manufacturers, you have different chassis made of different strength of materials. That is chassis. So next, coming to the transmission. So this mechanism is what transmits power from the engine to the wheels, controlling the speed and torque. From the engine, you have this gear system, right? The gear system will be connected to this transmission system, where all the four wheels will be connected to this gear system, and based on the power then generated by the engine, the wheels move faster or slower. Okay? So this is where it's controlled by the transmission system. The engine is the core part of the vehicle, the internal combustion or electric power source that propels the vehicle. Two types of engines. One is the ICE engine, which is the internal combustion engine, or you have the second type, which is the electric power. And nowadays you have a new generation of hybrid vehicles, which is a combination of both internal combustion as well as electric power. Okay. The next is the suspension system. The system of springs, shock absorbers, linkages that connect a vehicle to its wheels and providing a smooth ride and handling. ABS. ABS is a very critical part of nowadays all vehicles, is the anti-lock braking system. So this is a safety system that prevents wheel lockup during braking, so maintaining a smooth steering control. OBD is the onboard diagnostics. So this is a combination of the monitor which captures all the metrics of different parts of the car and reports the power of the vehicle's engine and other essential system. Right? Maybe the oil indicator, the fuel indicator, and whether your tire pressure is optimal or not. All these metrics are captured by the onboard diagnostics. HVAC, the heating, ventilation, and air conditioning. So this system is responsible for regulating the temperature as well as the airflow within the vehicle's cabin. The torque. So torque you might have come across in physics as well. It's a rotational force produced by the engine, influencing a vehicle's acceleration and the overall performance. Hybrid. Yeah, so a vehicle with both an IC engine and an electric motor offering improved fuel efficiency. Those are called hybrid vehicles. EV, a vehicle powered solely by electric batteries, producing zero emissions. RPM, the revolutions per minute. So this is a measure of the engine speed, indicating how many times the engine's crankshaft completes a full rotation in 1 minute. This is called as RPM. Payload. So the total weight a vehicle can carry, including the passengers as well as the cargo. This is known as combinedly, it's known as a payload. Passengers as well as cargo. Cargo is nothing but every vehicle have some boot space, right? And total luggage it can carry is known as the payload. So coming to the next right side, you have aerodynamics. So aerodynamics is the study of the flow of air around a vehicle, influencing fuel efficiency and stability. So if you have observed a different kind of sports car, right? Why it's designed in a very triangular shape where it's very down to earth, like it's very close to earth. It's have very ground clearance, and some vehicles have a very high ground clearance, right? Like SUVs or big vehicles. The lesser you have the ground clearance, the more aerodynamic a vehicle is. That's why it is used in sports vehicle where speed is very important. And some vehicles you don't really care about the speed. You care more about the comfort and you care more about the terrain, right? So those kind of vehicles do not need very high aerodynamics. It needs more comfort and a better suspension system. So coming to the horsepower. So horsepower is the unit of power management, indicating the engine's capability to perform work. Right, a engine is measured using how much horsepower it can produce. So telematics. So it's an integration of telecommunications and information processing for vehicle tracking, diagnostics, and connectivity. So telematics is like you have your Bluetooth, you have your radio, and you have your display within the car, right? So VIN number, the vehicle identification number. So this is something that you have to remember because in most of the automobile companies, if you join any company like Mercedes Benz, BMW, or any other car company, if you're working for that and you're analyzing data for the car company, this is a term you'll be coming across very often. So this is generated to track every single vehicle that is manufactured from the plant. So you have a database where you connect to different tables like in a snowflake model, right? Next is the ADAS. ADAS is the Advanced Driver Assistance Systems. So this is a very new concept that has come in where to enhance vehicle safety and improve driving experience, like adaptive cruise control. So what is adaptive cruise control, right? You're on a highway and sometimes you take want to take your hands off the driving wheel. So once you're at a certain speed, once you just enable the adaptive cruise control, you don't need to keep your hands on the steering wheel all the time, right? So the car will automatically drive at a certain same speed for some time. It will keep alerting you, right? If a car or anything is in the front, it will sort of alert you. That is adaptive cruise control. Lane keeping assist. Yeah, both. This is like cars having a very high-end features will have this kind of lane keeping assist feature, where it automatically tracks the white lines within the road, and it keeps you within the in between those two tracks itself. And if you want to move out of it, then you have to disable this so that you can go towards the safety service road, right? Automatic emergency braking. Yeah. So all this new kind of cars, right, like Tesla, or even high-end luxury vehicles like Rolls Royce and Mercedes also have this automatic emergency braking, where if a driver sort of dozes off, right, and there's a vehicle in front, the sensor automatically tracks that you're not slowing down, you're approaching a vehicle, and automatically enables the emergency braking. Telematics control unit is an electronic control unit responsible for managing in-vehicle communication, navigation, and connectivity. So when you say telematics, it's a combination of all the process like connectivity and diagnostic systems. But the control unit is actually the IC chip or the software chip inside, which is controlling or managing all this data coming in and out. Where that unit is called as a telematics control unit. ECU, another very important term that you all of you need to know. It's an electronic control unit. So nowadays all the car sensors and all the different telematics data are being handled by the ECU, right? Once all the parts have been assembled, there will be a specific spot where they do the in-assembly testing, right? So the diagnostics tool will be connecting to this particular ECU to retrieve all the diagnostics, and mainly for testing of all the different control units that is being controlled using this particular ECU, right? A computerized control unit that manages various electrical systems in a vehicle, such as engine, transmission, and braking. This is very simple nowadays because once they connect it to the tool, the ECU itself will give you the information of what all devices or sensors are working or not. Right? That is the ECU, a very core component of the car electrical system. Next is the OEM. OEM is also an important term, original equipment manufacturer. A car company will not make all the parts on its own. They will rely on multiple third party suppliers to supply them with different kind of parts, like the headlights may be a different company, the electrical wiring will be a different company. So each of these third party suppliers are known as original equipment manufacturer. Next is the digital twin, right? It's a new advanced technology where you can have a complete virtual replica of a car or even a total manufacturing plant in your computer system, right? So nowadays, what happens is when you want to set up a new manufacturing plant, maybe in a different company. Now your company is in Germany, you want to set up a plant in India, right? So there it takes many years of planning of how the plant will be assembled, how many robots are required. All this takes several years, several people to calculate. It is made much easier using a latest technology known as a digital twin, right? Several even cloud providers like Azure itself, they provide digital twin technology where you can have a physical, virtual replica of a vehicle. It's just like how you watch. There's this new vision glasses from Meta, right? So once you just put on the Meta glasses, you're in a virtual world, and everything seems very real, right? So that technology is also known as a digital twin. It's mainly used for simulation purposes. Next is the infotainment system. So the system in which it provides entertainment, information, and connectivity features, often known as audio, video, as and well as navigation. This is the infotainment system. The infotainment system is pretty much straightforward. Next is the drivetrain. So drivetrain is a combination of components that deliver power to the vehicle wheels, including transmission, drive shaft, and differential. So it's a very similar to the powertrain and transmission, right? Both of these things are quite similar. It's used in a different context in different companies. It's a components that deliver power to the vehicle wheels. Let's see how a manufacturing plant layout looks like. There's a very simplified dial down plant layout. On the left, you see different robots. Nowadays, almost I would say 80 to 90% of the car manufacturing is being taken over by the robotics in the plant, right from getting the sheet metal to assembling the different components. Most of it is taken care by the robotic process, but the important components like connecting your electrical systems, your steering wheel, your seats, all these are still taken care by the mechanics of the company. So if you see on the left, there is only one person that is just monitoring the different processes of the manufacturing, and on top all the different assemblies taken care by the robots. On the right, you see the actual plant layout. You will come across this a lot if you're working in a car company in production. So on the left, you have the engine. Once the engine is assembled, you have the chassis too. You have numbering, right? 1, 2, 3 till 10 on the chassis too. Those are the different stations, and each vertical is known as a assembly line. And every line will be having a line manager who's responsible for the smooth flowing of the vehicles. So just as you see, it's in sequence 1, 2, 3, 4, 5, 6, and you have after chassis 2, it is going to a green dots. Whatever you see, right? It's called as a buffer. If at all there is a problem with the car is taken out of the station and being fixed in the buffer locations. Sometimes the buffer stations also serve as a testing points, testing checkpoints, where the car is being tested if everything is working fine. So after chassis 2, it moves to chassis 3, and you have different trim lines. Trim lines is where you combine all the sheet metal into the actual frame of the car. Okay, and then it goes to trim 2, then chassis 1, chassis 2, chassis 3, where the different components like the transmission, drivetrain, everything is combined. And final one is where the electrical components are being assembled. Then you have the final two, different set of tests are being done, and you have the final inspection. And then the car comes out for the actual testing. So under inspect, you have different kinds of inspections that takes place. They do different wheel alignments. They see if the steering is proper or not. They see if the headlights are being aligned properly. Then you have a leak test where the car is being sent in a shower station where water is being sprayed at a high pressure from different angles, and they see if the water is seeping in, and different kinds of electrical testing again. So those are being done in the inspection station. Moving on. So let's see some of the different data architectures being used in a automobile manufacturing kind of a setup. So when you say manufacturing itself, as I told, there'll be a combination of multiple sensors of the robots as well as the cars. So all those comes under IoT devices. So you see in this diagram there are three verticals, right? The things, the insights, and then what actions you take. On the left is where you collect different metrics of the IoT devices like the plant, robots, different car metrics, and from data from different devices. All these are being connected to the cloud gateway or the IoT hub. From the IoT hub, it is being sent to different streams. One is for the live data, that is the stream processing. The next, you have the bulk data, which is being used for analytics. Right? You do the data transformation, you store it in the warm and cold path. The more frequently used data like retrieval as well as storing. So those kind of data is stored in a warm path, which is mostly used for stream processing, and the data which is accessed infrequently, right? Like once in a week or once in a month or once in a year. Those kind of data we store in a cold path store. Any analytical, it's called as OLAP, right? Any analytical data we do it in cold path, which will be used for machine learning and analytical. Anything which you need live metrics will be in the warm path. Once you have the reporting, you have the user management on the right, and then you have your business integration. So under actions, you will integrate it with your business tools, and then you have the user management here where you will give access to your reporting. So next is the industrial IoT data architecture. So you have the data coming in from different streams, data ingestion service, and then you have the stream processing. As we discussed before, there is a warm path, that means frequently used data or the streaming data. It goes to different services like Azure Event Hub, where a large number of requests it can handle. Then it is being sent to the Azure Analytical Services. It's stored in the warm storage, and you have Power BI accessing the real-time data. On the bottom, you have the batch layer, where the cold path or the analytical path, the event hub collects the information, and you have a time series data like for the past 1 year, for past months, what was the data. Those come under batch. You also have a Azure storage for archival. For future reporting, we store it in the Azure storage, which is a very cheap data storage solution on the cloud by Azure. And then you have a serving layer where you can do a batch views, different kind of SQL views according to the use case, like a SQL database, right? Where you will have different kind of views, like what is the sales for this year, what is the sales for last year. All these are different views. And then you have also, you can connect it to the Azure Power BI. So this is a data architecture for anomaly detection. So you have different kind of databases on the left, data sources, I would say. One is MySQL, blob storage, event hubs, Azure Cosmos DB, SQL database, and Postgres SQL. So these are the different databases, and every database will have multiple environments. There'll be a staging database and one for production. So whatever data is in dev will be only for development and testing. Staging will be sort of a pre-prod database, right? Once the application is up and running, you will be considering staging to be your actually pre-prod environment. And then you have the production, where it's a very critical database, and every production database will have backups, which is used for disaster recovery. So these are the things you need to understand. How many databases would you want? How will you handle a disaster recovery system in case something goes wrong? How do you retrieve the data back, right? So all these things you need to keep in mind. So after the data sources, you have the compute engines for pre-processing, aggregation, and post-processing. The Azure Databricks is a very powerful tool when you want to analyze big data. You have Stream Analytics for your live data, and you have your Synapse Analytics for building your data warehouses, data marts, mainly for data warehousing. And on top, you have your anomaly detector service. So this is part of a cognitive services from Azure. Any metric that is beyond a certain threshold, right? Normally you have certain thresholds, and immediately if a threshold is breached, you have a anomaly detector which alerts you that something has gone wrong. Next, you have a service bus. The anomaly detector also can send it to service bus. And then you have the application insights. So application insights, as I told before, is a diagnostics tools that whatever failures or requests have happened, success or failure, all the metrics are being captured by App Insights. It gives a detailed view and the timeline of the failures mainly. Then you have the Azure Data Lake Storage for your analytics and a serving layer here. It could be a web application or a Power BI reporting. So demand forecasting. So this is also one of the important ML term that is being used for predicting the demand, right? For companies like Amazon or Flipkart, we need to do a forecasting so that they know how many users are going to come here, how do we scale up the application. All these are very critical for a huge company. So what are the services you can use in Azure? You have the sample data on the left. You have the data factory for lift and shift of data between sources. You have SQL database. You have the machine learning studio in Azure where you can run your notebooks to do the demand forecasting. And the output of the machine learning you can visualize. You can either send back to the SQL database and it can be visualized in a Power BI, or even the sample data you can send it to the event hubs and the stream analytics, and you will be storing that data in the blob storage which can be later visualized in the Power BI reports. Moving on to the next is the vehicle telematics. So this we might see in the future. Currently not all vehicle metrics are being sent to the cloud, but in the recent times there have been very much importance in getting the data in the cloud because of more and more advanced features or digitization of the car itself. So these things are very important. So you have the diagnostic events which will be sent to the event hub on the cloud, and from event hub you have the stream analytics, and you have the machine learning studio. So all the data is being held in the blob storage in the cloud. You have HD Insight to process big data. You have again the data factory to do the moving data and orchestrating the data flow. And then you have the Synapse Analytics for building your data warehouse and data marts. And then finally, you have a visualization or reporting layer in the Power BI. Real-time vehicle data. This is sort of a very complex architecture which might be coming in the future, not right now. You have different services like Azure Sphere and Azure IoT Edge, which are very, very high-end real-time systems to monitor all the metrics. Right? You have different sensors, GPS, different kind of devices in your vehicle. Azure Sphere will make sure that your security and your data movement. So here you have on the middle, you have the ingest and device management. You have the IoT hub and security service from Azure Sphere. From there, it is going to the transformation layer in the Azure Stream Analytics, your storage, which could be your NoSQL Cosmos DB or Azure SQL or Synapse Analytics. Then moving to the serving layer, which can be your web and mobile apps. Even nowadays, you can control your car using your mobile itself, right? So this kind of architecture will make it a reality how you can control your car using this Azure architecture. You have the Power BI for reporting. You have API management to handle all the API requests. HoloLens is a very new service. On the bottom, you have the Azure Defender, which will is mainly used for firewall and security. The Azure DevOps is a CI/CD tool. Azure Monitor for monitoring your Azure services. Key Vault to store your sensitive information. Right, you have all your important API keys, and Azure Key Vault will store it securely for you. And the Active Directory for user management. And on the right most, you have all the different users that are going to use the serving layer. So that's about today's domain training session. I hope you learned some new terms about automobile manufacturing and important words that you need to know if you are going to work in a car company where you'll be working with different kinds of car related or plant production data.